And this is the physics of ultrasound, instrumentation, and the artifacts. If you understand this very well, you will be excellent in ultrasound in everything, not only OB and gynae. But if you miss this, you will stay weak forever. This is your chance now to understand everything. Now, let's see the history of ultrasound. The beginning is really, it is not tough, but maybe difficult for you. Just go with me step by step. Okay? What do we mean by the word piezoelectricity or piezoelectric effect? It is changing the electrical current to sound and changing the sound, which is mechanical energy, to an electrical current. This is the idea. So sonar was first used in 1940s in the wartime by submarines. But in diagnostic ultrasound, it was used in 1948. Okay, as they mentioned. So we understand what does it mean, piezoelectric. Piezo is electric compression and decompression, compression and decompression. So the ultrasound changed this mechanical energy into electrical energy, and the electrical energy into mechanical. How it happens? You see, the transducer itself, you give it electricity by the cable connected between the machine and the probe. You are sending electrical current. So by the tip of the probe, there's crystals. When you give electricity to the crystals, these crystals are the magic thing in the ultrasound. It converts the electrical current into mechanical waves, which is the sound. But actually, we do not hear it because it is more than our limits. Okay? That's why we call it ultrasound. So electricity into sound and sound into electricity.
Yes.
Now the voice comes, or the sound that comes out from your mouth when you speak, when it hits a strong reflector here, it will be reflected back to your ears in a form of echo, right?
Yes.
So you are sending sound and receiving the echo. Something very important, which is a must, to hear the echo. I will ask some questions, but I don't want the answer. It is just brainstorming, okay? What is the thing which is a must here? When you send sound to hit some reflector and the echo come back, to hear the echo, you have to stop sound. You have to stop, don't give sound. Just to give time for the echo come back. If you did not stop, you will not hear the echo that comes back to your ear. So the first thing you have to put in your mind, that you are going to send and receive, but you wouldn't receive if you are still sending. You have to stop to give time for the echo to come back to your ears, then you hear it. If you are just continuing giving sound, you will not receive the echo. This is very important in your transducer in your hand. It sends sound to the body, and the body reflects the echo back. Now, this probe should give me a pause after sending the sound, just to allow the echo to come back to the machine. Now, this probe is sending and receiving in the same time. I mean, not exactly the same time. It sends the impulse to allow the received echo to come back. If it keeps sending, the machine will not receive the coming back echo. This is very important principle in ultrasound. So that's why we do not send ultrasound pulses to the crystals continuously. We send on and off, on and off. Each on will give me echo. The echo will be on and off also. And this is what we call it, pulsed ultrasound. Pulsed, on, off. But if you give continuous, you will not receive. You will receive after you stop completely. Now, this is the emission of sound, either from you, these are the red lines, or from speaker, whatever, and this is the object. Now the reflection comes back, which is in green, back to your transducer. Why we make these lines? This line, it represents the sound waves. On, off, on, off, on, off. And so the coming back echo is on and off. Now the exact shape of the scent sound is exactly like the waves of water when you threw a stone in the water. When you throw a stone in the water, you will see these waves. It's a mechanical energy. The lines on and off, on and off. If you threw two stones in the same time, so you will have this groove cycle and the other groove cycle that could interfere with each other in this way. So this is the same. How does the ultrasound machine do when it sends sounds to the tissue or to the body? Now, the audible sound for humankind or mankind, it's between 20 hertz to 20,000 hertz. What does it mean, hertz? It's the frequency. Each hertz, each 1 hertz, is 1 cycle per second. If it is 20 cycle per second to 20,000 cycle per second, it's audible. If it is less, you cannot hear it. If it is more, you cannot hear it. Could it be less? Yes. Now the elephants and the horses and the dogs, they can hear what is subsonic, I mean below this frequency. And the bats and dolphins, they use the ultrasound which is above this frequency. Now this is the humankind here. Does it change in humankind? Yes, it is between, if it is between 20 to 20,000. Sometimes even it is more than 20,000, I mean more than 20,000 cycles per second. The young children, they can hear it and can see it. But the adults cannot see it and even cannot hear it. That's why we are Arabs and everyone, they know that they say there's a blessed boy or a blessed girl who can see angels and something like this, because they have frequencies not detected by adults, but it is detected by the young children. That's why they see something and hear something you cannot. And this is very scientific rule. It is not superstition or magic. Again, you give the electric current to the transducer, and the transducer have many crystals here. Each crystal has its own wires. Each crystal has 2 wires, one positive and one negative, because the electric current we supply to the transducer, it is a direct current, DC current, like the battery of your car. It is not AC, not alternative, okay? So you are switching the crystals here. The crystals now, this is the magic point in the crystal. that it converts this electrical current into sound waves. When it hit a reflector, what is the reflector? Skin, fat, subcutaneous tissue, muscle, bone, water, whatever inside the body, and will be reflected back in the form of echo. But always the sent is more strong than the received. Why? Because something will happen here in the media, which is the muscle and soft tissue and bone and cysts or something like this. Absorption, diversion, conversion, scattering, whatever. So the coming back echo is always less strong than the sound emitted. Okay? And this is the machine. You send electricity through the cable to the transducer. The transducer, through its elements here in the head of the transducer, changes this electricity to mechanical energy, which is the waves or the sound, the ultrasound wave that go to the tissue. And the reflected echo comes back to the same element. Now the same element, it do both. It converts the electricity into sound and converts the coming back echo also to electricity back to the transducer. And then what is received here by the receiver goes to the screen. What is the screen? Every screen is composed of big number of pixels. They are in millions. Okay? They are in millions. These pixels, the very small squares, if you concentrate on the screen, you will see there's very small screens here, squares here. These very small squares are lamps, like the lamp. When there's a strong echo comes back to the transducer will give me strong electricity. So you will see that square give me strong light. Okay? Hyper. So you will see strong light here. If there is no echo come back, it means there is no electricity goes to the screen, so these squares will remain unlighted. It will remain black. So according to the strength of the coming back echogenicity, which is fluctuating between strong and weak, it will give me if it is lighted high or lighted low or unlighted. So the summation of the brightnesses here on the screen, I can read what's going on. This is leg, this is mouth, this is eye. Did you understand the idea, the concept of ultrasound? Was it clear, Dr. Shaiman? Yeah.
Okay.
This is not a complex thing, but just to let you understand what's going on again in a brief. This is the transducer. We give it electric current. We call it intensity, or another name. We call it, what do we call it? The pulsar that give electric pulses to the transducer. The transducer, through the crystals here, change the electric current that I gave it to sound that goes to the reflecting interface, uterus, ovary, whatever, muscle. Now, this reflects back the sound in a form of echo. And it will be changed through the elements here into electrical current that goes to this area. This area, we call it the receiver. It receives it. So we can control it if it is strong or weak. We can reduce it or increase it by the sliding keys on the side of the keyboard of the transducer. You can increase it or decrease it. So the gain here is the function of the receiver. So you can control it, make it readable, and let it after that go to the display.